All right, so we've just went through the three types of linear systems of equations, the three scenarios that we could run into in a graphic kind of demonstration. So we went through it using pictures, okay? So we used three graphic examples to show what these systems could be in terms of dependent, independent, consistent, and inconsistent properties. Now let's go through it algebraically. So instead of giving you a graphic scenario, well, let's evaluate this graphic scenario. If I were to tell you that these are parallel lines, you should be able to say that they are independent lines because they differ in some aspect of their equations. They're parallel, so they don't differ in terms of their slopes, but they will differ in terms of whatever their y-intercepts are. So they're independent lines, and they're inconsistent, okay? Now, you wouldn't know that these are inconsistent if I didn't tell you they were parallel, because they might slightly be just askew so that maybe in 20 feet from here, they would end up meeting. But if I'm telling you that these are parallel lines, then you know that they are inconsistent. They are inconsistent because they will never ever meet. And if they never meet, they'll never have a common solution. So parallel lines are going to be independent and inconsistent, and you can tell that through the picture. However, let's say that we're not using a graphic example. All right, let's say we're using an algebraic example. Let's say I write two equations of two lines, y equals 3x plus 4 and y equals 3x plus 9. All right, I'm not showing you any pictures, but you should be able to tell me, is this a consistent or inconsistent scenario, and is this an independent or dependent scenario? So we see that these lines both have the same slopes. Okay, so we know at this point that since they have the same slopes, they could either look like this, parallel lines, or they could look like this, where one line is on top of the other line. We don't know quite yet by just looking at the slopes. But if they have the same slope, they're either going to be parallel lines or they're going to be two lines on top of each other. That's why we need to continue to look at the y-intercept. The y-intercept will tell us whether it's scenario dependent or a scenario of parallel lines. Since these are two different y-intercepts, we can rule out the fact that they're the same line anymore, that they have the same y-intercept, and we can now rest assured that we have a parallel line situation here. Therefore, even with not writing any of these illustrations out, just by analyzing the numbers in these two equations, we could say that they are parallel, and thus they are inconsistent, and independent, just by looking at the properties of these equations. In the next video, we'll try another one.